Assalamualaikum warahmatullahi wabarakatuh. We are from Group 8 and today we will present our chosen question which is July 2021.
For the first question, we were being given the probability in events T, Q, and R, and also the probability in intersection between events T and R, also intersection Q and R. We're going to start off by drawing our Venn diagrams and label them as a T, Q, and R, then draw the universe around the outside. Now it is important to read through all of the information. So we were told that the probability in event T is 0.3, event Q is 0.2, and event R is 0.5. So how to find the probability in event T only is to minus the value 0.3 with the probability in intersection between T and R. Same goes to event Q only and R only. For the question to Roman, the question asks for the probability in event T union Q and absolute R. For the first step, find the probability in event T and also the probability in event Q absolute R respectively. Then add up those values and we will get the final answer 0.56. Now we move to question 1b. The question asks for arrangement in the word recruitment with the conditions. The first letter must start with R and the last letter is E. For the first step, separate the letters according to the conditions. Count how many letters in each group, then do the calculations for every group of letters, and the answer must be multiplied. And we will get the total of arrangement is 2520. This question has a condition. All vowels must be separated. Number of arrangements when all vowels occur together must be minus with the total number of arrangements. The total number of arrangement is 11 factorial divided by 2 factorial times 2 factorial times 2 factorial. While the number of arrangements when all vowels occur together is 4 factorial divided by 2 factorial times 8 factorial divided by 2 factorial times 2 factorial. Do the calculations one by one, and the last answer we will get 4,868,640. The question asks for how many ways can 3 marbles drawn from the box if at least one black marble is to be included in the draw. So we use the combination formula. Start with 3c1 times 6c2 equals to 45. Then 3c2 times 6c1 equals to 18. Then last one, 3c3 times 6c0 equals to 1. Then we add up those answers. 45 plus 18 plus 1 and we'll get the answer 64. For the last question, it is asked for the probability for at least one black marble was included in the draw. As we know, the arrangements without condition in this case is 126. So we use the formula to find the probability for black marbles to be chosen, which is NB divided by NS, and we will get 74 divided by 126. We will get the final answer 0.5873.
For question 2a, we will need to draw a tree diagram. The first branch will be labeled as PR with a probability of 0.75, and as for the second branch, it will be labeled as PR prime with a probability of 0.25. The R and PR indicates that the loan has been repaid, and R prime is unpaid loan. We will then extend the first branch, PR, into 2 more branches, PMR and PM prime R, with a probability of 0.25 and 0.75 respectively. As for the second branch, PR prime, we will also extend it into 2 more branches, which are PMR prime and PM prime R prime with a probability of 0.85 and 0.15 respectively. The M indicates that they have been employed for less than 2 years, whereas M prime indicates that they have been employed for more than 2 years. Next, for question 2b, we will need to find the probability of a loan applicant that has been employed for less than 2 years. First, we will need to multiply the probability of PR and PMR, which is 0.75 times 0.25. We will then multiply the probability of PR prime and PMR prime, which is 0.25 times 0.85. After that, we'll add both of the answers together and we will get the probability of PM, which is 0.4. Lastly, for question 2c, we'll need to find the probability of an applicant that has been employed for more than 2 years and that they will repay the loan. First, we'll need to find PM prime. To do this, we will calculate 1 minus PM. We already know the answer of PM from the previous question, so we will calculate 1 minus 0.4. The answer will be 0.6. Next, we will calculate PRM prime. For this, we will multiply PM prime R and PR. After that, we will divide it by PM prime. So it will be 0.75 times 0.75 divided by 0.6. We will then get 0.9375 as the final answer.
So question 3a, draw a tree diagram with all the possible outcomes and probabilities if Aidan can only play the game once. So for the tree diagram, first they have 2, which is PH and PT. PH is probability for head and PT is probability of tail. So the probability of PH is 1 over 2. Also the probability of PT also 1 over 2. Then for PH, they also consist of 2, which is PD and PW. PD is probability of dark chocolates and PW is probability of white chocolates. So for PH, is the probability is 8 over 13, while for the probability of pH to PW is 5 over 13. After that, the PT also consists of two, which is PD and PW also. PD is probability of dark chocolate and PW is probability of white chocolate. So PT to PD, the probability is 6 over 12, and PT to PW, the probability also 6 over 12. Question 3b. Construct the probability distribution table if random variable x representing item selected the dark chocolate. So first column is elements of sample space, second column is probability, and third column is x. So first element is HD or head dark chocolate with probability 4 over 13, x equal to 1. Second element is HW or head white chocolate with probability 5 over 26, x equal to 0. Third element is TD or tail dark chocolate with probability 1 over 4, x equal to 1. Then fourth element is TW or tail white chocolate with probability 1 over 4, x equal to 0. Then for the second table is first row number of dark chocolates x and second row is probability. So for x equal to 0, the probability is 23 over 52, and for x equal to 1, the probability is 29 over 52. The total of Px equal to 1. Question 3c. Calculate the mean and variance of selecting white chocolate. Before that, I made the first table with first column is elements of sample space, second column is probability, and third column is y. First element is HD or head dark chocolate with probability 4 over 13, y equal to 0. Second element is HW or head white chocolate with probability 5 over 26, y equal to 1. Third element is TD or tail dark chocolate with probability 1 over 4, y equal to 0. Then the fourth element is TW or tail white chocolate with probability 1 over 4, y equal to 1. Then I make the second table with which first row is number of white chocolates y and second row is probability py. For y equal to 0, the probability is 29 over 52, and for y equal to 1, the probability is 23 over 52. So the total of py equal to 1. Then I can find the mean. So the formula of mean is mel equal to e multiplied by y equal to 0 multiplied by 29 over 52 plus 1 multiplied by 23 over 52 equal to 23 over 52. So the mean is 23 over 52. Then I find the variance. Before that, I find the ey to the power of square to the power of 2 equal to 0 to the power of 2 multiplied by 29 over 52 plus 1 to the power of 2 multiplied by 23 over 52 equal to 23 over 52. So I can put the ey to the power of 2 into the formula variant y equal to ey to the power of 2 minus ey to the power of 2 equal to 23 over 52 minus 23 over 52 to the power of 2 equal to 667 over 2704. So the variant is 6067 over 2704.
Question A. Find the probability that in one day Amanda spends time to read less than 72 minutes. 72 divided by 60 equal to 1.2 hours. Probability y less than 72 equal to probability y less than 1.2 equal to limit 0 to 1 y dy plus limit 1 to 1.2 2 minus y dy. To differentiate, we will get y squared divided by 2, the limit of 0 to 1 plus 2y minus y squared over 2, the limit of 1 to 1.2. Integrate and we will get 1 squared over 2 minus 0 plus 2 multiply 1.2 minus 1.2 squared over 2 minus 2 multiply 1 minus 1 squared over 2 equal to 1 over 2 plus 1.68 minus 1.5, and we will get the answer is 0.68. Next question B. Find the cumulative distribution of y. Function y, the limit of 0 to y t dt equal to t squared over 2, the limit of 0 to y equal to y squared over 2. Function y equal to the limit of 0 to 1 t dt plus 1 to s 2 minus t dt equal to t squared over 2, the limit of 0 to 1 plus 2t equal to t squared over 2, the limit of 1 to s equal to 1 squared over 2 minus 0 plus 2s minus x squared over 2 minus 2 multiply 1 minus 1 squared over 2 equal to 1 over 2 plus 2s minus x squared over 2 minus 3 over 2. And we get the function y is equal to negative x squared over 2 plus 2x and minus 1. Question C. Calculate variance 2 plus 3y. We have to find the mean first. Ey, which is means, equal to the limit of 0 to 1 y multiply y dy plus the limit of 1 to 2 y multiply 2 minus y dy. After multiply, we will get the limit of 0 to 1 y squared dy plus the limit of 1 to 2 2y minus y squared dy. After differentiate, we will get y cubed over 3, the limit of 0 to 1 plus 2y squared over 2 minus y cubed over 3, the limit of 1 to 2. Integrate, we will get 1 cubed over 3 minus 0 plus 2 multiply 2 squared over 2 minus 2 cubed over 3 minus 2 multiply 1 squared over 2 minus 1 cubed over 3 equal to 1 over 3 plus 4 over 3 minus 2 over 3. We will get the answer is 1. After that, we have to find the ey squared equal to the limit of 0 to 1 y squared multiply y dy plus the limit of 1 to 2 y squared multiply 2 minus y. After multiply, we will get the limit of 0 to 1 y cubed dy plus the limit of 1 to 2 2y squared minus y cubed dy. After differentiate, we will get the y the power of 4 over 4, the limit of 0 to 1 plus 2y cubed over 3 minus y the power of 4 over 4, the limit of 1 to equal to 1 over 4 plus 4 over 3 minus 5 over 12, and we will get the answer is 7 over 6. We have to find the variance of the function y equal to ey squared minus e in the bracket y to the power of 2 equal to 7/6 minus 1 squared. We will get the answer 1/6. And lastly, we have to find variance 2 plus 3y. Split that into variance 2 plus variance 3y equal to 0 plus 3 squared multiplied with variance y equal to 9 multiplied with 1/6, and we will get the answer 3/2.